Okay, ladies and gentlemen, you are on page 15, lesson 2.5, where we are discussing linear and non-linear relations. So a relation is any connection between two variables. So you have an independent variable and a dependent variable. There's usually some kind of relation between the two. If it's linear, which is our first note here at the very top, a linear relation, and that marker is
linear,
is a relation between two variables that forms a straight line when graphed. A relation between two variables that forms a straight line when graphed. An example of this would be, I guess, just really easy. Don't draw this, but the number of years you are alive and the number of days you are alive. That will be a perfectly straight line, because every year has the same number of days, except for leap years, I guess, so it's not entirely perfect, but the number of years you're alive and the number of days you're alive will form a perfectly straight line. Okay? Now when we're graphing real data and scatter plots and things like that, you really never get a perfectly straight line. You never get dots that all line up exactly, okay? But we can represent that data with a straight line, called a line of best fit, which we get into next. So first things first, a linear relation, a relation between two variables that forms a straight line when graphed. Yes?
I was just asking about part of this.
Yeah, we're going to get there. Nice. A little note. Often, you can use a linear relation to model the data on a scatter plot. So the linear relation isn't the data. It doesn't represent the data perfectly, but it can model the data. It means you can look at that linear relation and say, oh yeah, the data follows this trend. Often you can use a linear relation to model the data on a scatter plot. This linear relation corresponds, so it's directly related to, it corresponds to a line of best fit. So, our next note, line of best fit. This is a straight line that comes closest to the points on a scatter plot. A straight line that comes closest to the points on a scatter plot. One of the rules for drawing a line of best fit by hand is that once you draw it, it should go through as many points as possible, and it should have equal number of points above the line as below the line. Kind of makes sense, right? That's an easy way to help us draw it by hand. Okay. Another note. Many non-linear relations can be modeled, not with a line of best fit, but can be modeled with a curve of best fit. So sometimes the correlation is kind of curves upward a little bit, and then we could use a curve of best fit. Okay? There's that example. So, what's a curve of best fit? This is your last little note. Curve of best fit. Just like a line of best fit, except it's a curve. That comes closest to the points on a scatter plot. Now, if your data looked very linear, that there was a linear correlation, then you would use a line of best fit. You wouldn't use a curve of best fit. If it looks like it's not linear, then you would say, okay, I'm going to apply a curve to this, whether it's a positive curve or a negative curve, or maybe it curves like this, right? Lots of different options.
Do you ever have a curve that goes like up and down on the same line?
You could if you had something called a sinusoidal function, which means a repeated function. So let's say you're on a Ferris wheel, and the amount of time that you're on a Ferris wheel, like time just keeps going, but the height of the cart of your Ferris wheel would go higher and lower, higher, lower, higher, lower. So that's a sinusoidal function. It repeats itself. You get into that in grade 11 a little bit, and then grade 12 more. Okay, so we're in our notebook on page 15, and we have example 1. We have use a line of best fit. So I don't know what that is, the gymnophthalmid lizard. The gymnophthalmid lizard lives in the Amazon rainforest. Recent research has found that this lizard keeps its body temperature close to the temperature of its surroundings. The table below lists the data from this research. So I'm going to give you the lizard temperature now. I'm just going to read it out for you, and you can fill in the boxes there. So starting underneath 25.0, you're going to write 26.2, then 28.2, 29.7, 30.3. Underneath 28.2, you're going to have 29.8, then 28.3, then 27.6, then 30.8, 29.5. Underneath 28.4, you're going to have 30.0, then 28.8, then 28.7, then 29.0. All good?
What's the second and the fourth?
Underneath 24.8, you have 28.2. And underneath 30.3, you have 30.3. Good? Okay, A, graph the data. So you have a very faintly in your notebook there, you have a grid. And we are going to graph all this data. Again, first thing that we're going to do is identify dependent or independent variables. So what's the independent?
Surrounding temperature.
Surrounding temperature. So you can write that on your horizontal axis. And the dependent variable, lizard temp. That is your vertical axis. I'm just going to help get you started. I'm not going to draw it because I don't have a nice grid to do it really neatly. Down here we have surrounding temp, and we want to make sure we note that it's done in Celsius. So that's degrees Celsius. And over here we have lizard temp, which is also measured in degrees Celsius. Okay. Are we going to start at 0 with our data, or are we going to use a broken axis? Okay, so let's break them. 1 up, down, out, left, right. And what's the lowest value that we have for surrounding temperature? It's going to go here. So our lowest one is 24.6 or 8. So yeah, let's start at 24. And our highest value? Surrounding temperature? 30.3. So, yeah, as long as you leave a little bit of tail over here, you can write 30. And then you go ahead and think about how that needs to get split up. On yours, since your graph is there, you might not even write 30 there. You might work from left to right. If you don't have a graph, it's easiest to, that's not in the middle, but it's close enough.
Is this a bar graph?
627, let's see, that's 27, 26. And this will be a scatter plot. Okay, so you're going from 24 to 30. And what about lizard temperature? Do the exact same. Go ahead and carefully plot all of your ordered pairs, all of your corresponding data, and then we'll analyze this graph. All right, B asks, how are the two variables related? How are they related? What's happening here?
They're like two different groups.
So the data is kind of in two different groups, okay? How are the variables related? How is surrounding temperature related to the lizard's temperature?
The lizard's temperature depends on the surroundings.
Lizard's temperature depends on the surroundings. So we could say, as surrounding temperature increases, the lizard's temperature increases. So there is a clear trend. So for B, let's jot, there is a clear trend. Right? You wouldn't look at this data and say, oh no, they're not related at all. They're wrong. Scientists are wrong. The lizard's body doesn't adjust with surrounding temperature. You'd look at this and you'd say, oh yeah, there's a clear trend there. I get that. That makes sense. Okay? And then we'll write what we said. As surrounding temp increases, comma, lizard body temp increases. As surrounding temperature increases, the lizard's body temperature increases. Is this relationship linear or nonlinear? Should we be drawing
It's linear.
a line of best fit or a
Linear.
curve of best fit?
None. No, a line.
A line.
I'd
None.
say it's close enough to being linear. We can classify it as linear because the data points lie close to a straight line. Although the relationship is not perfectly linear, a linear relation is a good model for the data.
And linear is a line, right?
Yes, linear means line, yep. So in step 3 we're supposed to draw, are we drawing a line of best fit or a curve of best fit?
A line.
Line of best
Leave
fit.
a line.
Okay, go ahead and try to draw a line of best fit. Remember, the line should be as close to the points as possible, and if
Yeah,
possible,
that
it
you
should
want.
go through points, and it should have as many above and below the line as possible. Or sorry, the same amount above and below the line-ish. So again, my data isn't perfect because I don't have a grid, but this is kind of what my line of best fit might look
We
like.
have 4 above and 5 below.
You don't have
David.
Oh, I didn't make it straight.
Does it matter if I have like 7 above, 6 below, and 1 below the line?
No, close enough. It's just an estimate, right?
Ooh, 6 above, 7 below.
Now that you've done that, look at D. We're going to estimate the lizard's body temperature using your line of best fit when the surrounding temperature is 26 degrees. So basically all you're going to do is you're going to think, okay, straight up from 26 degrees, where do I hit on my line? If I look across, I'm at,
8.2.
yeah, I'm right around 28 degrees. Okay? So you're using your line of best fit, which doesn't have to be exactly the same as mine, to estimate the lizard's body temperature, and we could even put like a little squiggly to say approximately. Is that interpolation or extrapolation? Interpolation.
Wait, what is
Good.
interpolation again? I know what
Interpolate means you're within the data that you've been given.
Oh.
26 falls in between 24 and 30. So it's interpolation. Now in E, we need to estimate the lizard's body temperature when the surrounding temperature is 35 degrees Celsius.
Extrapolation.
Extrapolation. So now our graph probably isn't quite big enough, but if you extended your line of best fit beyond the graph, and you kind of thought, okay, 35, this would be 31, 32, 33, 34, 35, and now we're looking all the way up
It would be like 35.
and across.
I'd say it would be like 37.
It's 35.
No, it's probably like 40.
No.
Yeah.
I have.
It's 36, yeah.
Anywhere in the
36.
35 to 37 range is good enough, but we would draw a dotted line all the way up, straight up, and then we'd look straight across, and that would be our estimation. Okay, that's extrapolation because we're estimating a value that is outside the measurements given. I'm going to briefly explain your homework to you for 2.5. It's found on page 516 and 517. It doesn't look typical. It's a bunch of different activities. So you're going to do all of the activities from 516 to 517 in preparation for tomorrow's class.